Receiving your content, your audience will see it in a moment. All right, I am live. There's nothing else I need to push, right? Well, easiest way to double check is to actually look at another device. My channel. Hey, it shows that I'm live. Perfect, and sound is working too. I wanted to double check and make sure because a friend of mine was streaming and he had said there was a button he forgot to press or something, and he thought he was streaming through OBS, but then he wasn't, and that obviously wasn't a good situation. Okay, so we'll be getting started in about a minute or so. I just wanted to start up early, make sure that the stream was working the way I wanted it to be. And it does seem to be working right now. We're going to be doing some Rust programming these mornings. And also, I just want to sort of like reiterate, because this is the first of the official streams on YouTube for this month, is that this month I may or may not be changing. Well, it's more of I'm testing out streaming on YouTube. Previously, for a while before I had taken a break from streaming, I was on Twitch. And that's great and all, but it is definitely not sort of geared towards create like the programming streams. Like the service is fine. The people that are on watching streams are more on there for gaming and for other things or making games. And if I'm just making art or making other cool little things, I'm gonna try YouTube out, see how it is, and at the end of the month make a decision of whether or not I want to go back to Twitch and continue building that channel up, or if I want to make the more permanent switch over here to YouTube. All right, it is 7 a.m. Mountain Time, and that means time to start going through this book again. So in C, after my last stream, I sort of played around with the book a little bit just to see if it was something that I wanted to learn and do. I did want to sort of like get back into using the systems language, and initially my thought was using C. And then I was reminded that Rust exists, and Rust is sort of it's a very modern language, and it's adding a lot of interesting things, like for example, preventing segfaulting and guaranteeing thread safety, which obviously you don't get in C, but I believe that you still have to deal with your own memory management. You still have to deal with everything else yourself, which is very C-like. So I went through the first chapter, which was the Hello World chapter. And what that is okay, we're declaring a function main, which just like in C, you must have a main function. And then there's the print line, and they were quick to point out that because of this exclamation point, it's not a function, it's a macro, I believe, and they act very differently than functions, but also at the same time very similarly to functions. So we'll probably be dealing with that ourselves. Other than that, it looks pretty much the same as most other programming languages here. It is a compilable language, which is why we now see this main file here, because it's binary. And then we also went through and saw, okay, well, there's this idea of cargo, package manager essentially for Rust, but it does a little bit more. You also use it to build your code, and it will turn it into the target. where you can, where was it? It was in debug. Oh, hello cargo. And then it builds it to here. And then you can also build it for production, and amongst other things. So it does sound a little bit interesting. It's also possible to install packages similar to like npm packages or pip packages or gems, all for cargo. So this is the Rust website. And what I want to do is go through the official Rust book. It looks like they have 2 editions here, but we're going to be going through the 2nd edition, even though it is still under construction. They do claim that it's far enough along to learn most of Rust, so that's what we're going to be doing. If we really need to sort of like go back and look at what other things are there, we can do that. All right, so we already did installation. I have it installed. Let's double check what version I've got. Rust-v. Oh, it's Rust C-v version 1.25.0. Okay, so we're on to chapter 2, the guessing game. I'm going to close this, create a chapter 2. Why did you go in there? Yes. There we go. And it's the guessing game. All right, so let's jump into Rust by working through a hands-on project together. This chapter introduces you to a few common Rust concepts by showing you how to use them in a real program. Okay, let and match methods, associated functions using external crates, and more. We'll implement a classic beginner programming problem, a guessing game. Program will generate a random number between 1 and 100. It will then prompt the player to enter a guess. Oh, it feels like the opposite of what the games that I usually have made previously, which is where the computer guesses. But okay, we'll... that's a nice simple one. Set up a new project. Set up a new project, go to projects, and make a new project using cargo. Okay, so I created that new folder. I want to cd into chapter 2, and inside of here, I'm going to move that to the right. Inside of chapter 2, we're going to use cargo to create a new guessing game, and then we're telling it that it's a binary. So cargo, new guessing game, dash dash, binary. All right, so it created a guessing game for us there. And here this is, here's our source, and it gives us just a hello world in there. Oh yes, and there's this toml file, which is similar to YAML for other configurations, but it's T instead of Y. Okay, so package name guessing game. All right, this is all fine. I'll go to the hello world. Now let's compile this hello world and run it. So yeah, they could do a compile and run at the same time. So cargo run, I think it's just cargo run. Oh, I need to cd into, where am I? I'm already in chapter 2. I need to cd into guessing game. Then I could do cargo run. And then we get our hello world here. Okay, that's cool. The run command comes in handy when you're yes. I'm actually going to make this a little bit smaller so that we don't, it's either smaller or bigger so that it doesn't have our commands wrapping around quite at such an awkward position. First part of the problem will ask for user input, process the input, and check that the input is in the expected form. Okay, so here's our main use standard IO. So this looks to me like it's like the import std IO from C. So we're going to pull that in. I wonder if there's a similar way in C to have like just a global headers and just say, hey, just import everything, and it'll figure it out when you compile it. But all right, so we're going to say use standard. The double brackets is a little bit interesting. We'll see what that means hopefully soon. Then we have our function main print line. So we have to tell them, guess the number. And then we have another print line, please input your guess. Now my guess is that, is this print line going to have an auto /n? Hopefully it does. Print line, and then please enter your guess. Okay, I'm gonna make this slightly smaller so it fits. Okay, so let guess. So we're gonna create a guess variable, but we're also gonna set it as mutable, because I was reading earlier that that every single variable in Rust is immutable by default. We have to give it this flag to tell it it is mutable. It's going to be type string, and we're running. Okay, so this must be running a function essentially off of string. Okay. And this is going to be inside of here. So let it's a mutatable guess equals string. Either we're accessing the new function inside of it. And then so we imported IO from standard. That's what this is. So now we can do IO is an object or some kind of data structure that we can access standard in from. So IO standard in dot read line. So we call standard in. This must be like because when we call a function, it usually returns. This must be the same type of idea as JavaScript. Whatever is returned from here must be then accessible by the dot. So return some kind of object or something that we can that has a method read line on. And now if this is like C, this symbol, maybe we're passing the location of the memory address to read line so they can update guess easily. %mute guess. It's interesting that we have to give mute guess again and not just guess. Also interesting that they're having this be continuation of this line. I guess it doesn't matter because every line is ended by semicolons. It understands that, okay, we can't do that. I could also just do dot. We kind of want to do this now. Return you, tab you in, return you, tab you in, dot expect. Okay, so if there's an expectation, if there's some kind of failure, it'll tell it failed to read line. I would almost think that it's like except or on fail or catch. It's interesting to make it expect. Okay, and then we have print line. You guessed, and then we're going to say what the guess is. That's an interesting symbol to use there. I guess this guess is going to be put into these brackets here. That's my guess about the guess. Listing 2-1 code. Okay, so here's all the code, and we're going to go through it now. To obtain user input and print the result as output, we need to bring the IO input output library into scope. The IO library comes from the standard library. Okay, so they don't really explain the double colons here, but they just say like, hey, that's how we can bring in the IO library. All right, so we need to do the main function. The fn syntax declares a new function. The line is a macro that prints a string to the screen. Okay, so then we have our let mute guess equals string new. In Rust, variables are immutable by default. The following example shows how to use mute before the variable name to make a variable mutable. Is it mutable within its type, or is it mutable outside of its type? My guess is that guess cannot be anything other than a string, but it can be different strings. And I'm guessing that if I wanted to not have this be mutable, I could probably destroy and release the variable from memory and then recreate it again in order to grab it back and then keep it immutable. Now that you know that let mute guess will introduce a variable named guess. On the other side of the equal sign is the value that guess is bound to, which is the result of calling string new, a function that returns a new instance of a string. String is a string type provided by a standard library that is growable. Okay, so right now it's empty. This just returns the type essentially. Okay, the double colon syntax in the new line indicates that new is an associated function of the string type. An associated function is implemented on a type, in this case string, rather than on a particular instance of a string. Some languages call this a static method. All right, so that makes a lot of sense. This new function creates a new empty string. You'll find a new function on many types because, so this is, I'm assuming the appropriate way of doing it because I can't just say, okay, I'm going to create a string this way. Instead, I want to use the official string new function that returns a string, but it also sets it up. Hey, Danny, welcome to the stream. Yes, Rust indeed. We're going through the book. Okay. Unmuting this microphone is difficult. Okay, so if we didn't have the use standard IO line at the beginning of the program, we could have written this function. Oh, yeah. That the double colon syntax is a little bit interesting of like accessing these associated methods inside of another object. Okay, the standard in function returns an instance. Yep. It's a type that presents a handle to the standard input for your terminal. The next part of the code, read line, you'd guess that's this one. Calls the read line method on the standard input. I wonder, do they, oh yeah, it looks like they're going to talk about that. Okay, so string argument needs to be mutable, so the method can change the string's content by adding a user input. And then the @ symbol is a reference. So that's what we thought, is that it is a reference to the position in memory. This gives you a way to let multiple parts of your code access one piece of data without needing to copy it into different memory points. Yep, references are a complex feature. One of Rust's major advantages is how safe and easy it is to use references. You don't need to know a lot of those details to finish this program, but Chapter 4 will explain references more thoroughly. So that is something that we run into C every once in a while, is fun memory things like accessing things that you shouldn't access by accident or potentially on purpose. Yeah, easy. Yeah, everybody that I know that has been sort of getting into Rust basically says, oh, it's totally easy. No, it's not. It's really hard. Okay, for all you need to know is that, like variables, references are immutable by default. Wait, references are immutable by default? Hence we need to write immute guess rather than get. Okay, so that totally makes sense now. So even we now make the the reference to the mutable variable mutable. That's weird. I still feel it's odd that they put it here instead of here. Or maybe that's just my mind like having trouble seeing it, because I'm just so used to putting it right here. We're not quite done with this line of code. Although it's a single line of text, it's the first part of the single line of logical code. Yep, there's this expect, which also interesting, the word expect. I was like, I'm so used to catch. Mute name syntax bothers me. Verse name instead of. Oh yeah, so you would prefer, you would prefer something like this, right? Where you put the symbol in front of here, and then just have that be what we passed in was the mutable guess, or the reference to the mutable guess. Yeah, I could see that. But smart people made this language, so I'm sure they had a reason, and we now have to live with it. Name is valid. At name would get formatted to at. Oh, really? So if I put a space in front of it, it would change it. Although they didn't have the installer for the thing that auto formats my code, so I don't think I have that. But that is interesting that this would work too, but it's just the same as this. Okay, so when you call a method with the .foo syntax, wait, hold on. Not quite. The second part of this method, .expect. Okay. It's often wise to introduce a new line and other white space to help break up the long lines. Yes. If you run cargo format and so wait a second. Let me try that. I should save this first. There we go. Let's try cargo format. Cargo format. Cargo install format. It can't find that. Or maybe it's cargo install cargo format. No. Those don't seem to exist, unfortunately, on this system. Okay, as mentioned earlier, readline puts what the user types into the string we're passing it, but it also returns a value, in this case, IO result, which this is a number of types named result. So they have a generic result, and then they have IO result. Is IO result a child, like a instance of the generic result? That would be interesting. The result types are enumerations, often referred to as enums. An enumeration is a type that can have a fixed set of values, and those values are called the enums variants. For results, the variants are okay or error. Okay, so the purpose of these result types is to encode error handling information. An instance of IO result has an expect method that you could call. If this instance of a IO result is an error value, expect will cause the program to crash and display the method that you passed as an argument to expect. If the readline method returns an error, it would likely be the result of an error coming from the underlying operating system. If this instance of IO result is an OK value, expect will take the return value that is OK. It's holding, so it won't run the expect. Oh, interesting. And it wouldn't tell me specifically to use expect. It just warn unused must use. It's in a result which must be used. So I must use something with result, and expect will basically do that. Rest warns that we haven't used the result value. I'm guessing that there's going to be more, they're going to introduce us to more things off of result, and expect is only one of them. There's probably the other one, the OK. Printing values with placeholders. Okay, this is a crazy looking one. These two brackets, they do not look like that they're placeholders. This line prints out the string we saved to user input. The set of brackets is a placeholder that holds a value in place. You can print more than one value using. So if I wanted to like format like a value with multiple decimal points, would I put stuff inside of here? Probably. You could print more than one value. The first set holds the first value, and so on. Well, this makes it so I don't have to remember what types and do /d/s/c all the time. I remember that was fun with C. Let's test the game and see if this first part works. So cargo run. Guess the number, enter your guess. We'll do 50. You guessed 50. All right. Generate a secret number. So we need to figure out random numbers, maybe off some kind of standard math library. Next, we need to generate a secret number that the user will try to guess. The secret number should be different every time. Let's use a random number between 1 and 100 so the game isn't too difficult. Rust doesn't yet include random number functionality in its standard library. However, the Rust team does provide a rand crate. Using a crate to get more functionality. Remember that a crate is a package of Rust code. The project we've been building is a binary crate, which is an executable. The rand crate is a library crate which contains code intended to be used in other programs. Cargo's use of external crates is where it really shines. Well, yeah, like most languages with a package manager, I mean, that's where all those languages shine, really. We need to modify the cargo toml file to include the rand crate as a dependency. Well, wait a second. If I just do cargo install, will that add it as a dependency? Cargo -h. I want to make this bigger. Okay, so we have install Rust binary. Can I do like help off of this? So like cargo install -- help. Oh boy. All right, let's. Get URL rev. Doesn't look like there's anything crazy here. Only packages that have bin targets can be installed. I'm wondering here if it can if it will just auto put in, and I think we should just try it. So cargo install rand. Specified package has no binaries. Interesting. Did it put that information into... No, it didn't update my dependencies. Rand is a -- lib crate. Oh, so I have to do cargo install -- lib rand. Did you mean -- bin? No, I did not. All right, well, let's do what the book actually suggests. So it's under dependencies, rand 0314. Interesting. This one was rand 050, but we'll try their specific locked version. Rand equals 0.3.14. Okay, so the dependency sections where you tar cargo, which external crates. Cargo tried to grab a pre-release. It did. In this case, we'll specify the rand. I guess if you don't give it a version number, it's going to get the latest version, even if that's a pre-release. That kind of sucks. Any version which is public API compatible with version 3.14 or 0.3.14. Okay, so if we just do build, and now it's gonna install everything it needs to. There we go. The output from cargo run. Let's see. Now that we have an external dependency, cargo fetches the latest versions of everything from the registry, which is a copy of data from crates.io. Is that a website where we can search for the crates? So rand. Yeah, here's this pre-5. $0.42. It looks like that's the newest one. Okay, if I copy this and I replace you and I build you again, will you auto grab that? Cargo build. No, it didn't auto grab the latest. Oh wait, it did. Okay, so it didn't auto lock me into 0314. It downloaded all of these different versions of Rand. I don't know how I feel about that. Like, I feel like it ignored what I said in the toml file and did what it wanted to. I feel like that feels wrong to me, but I'm going to ignore it for right now. If you immediately run cargo build again, you won't get any output because I have to download it again. These lines show cargo only updates that build with tiny changes. Your dependencies haven't changed. The cargo lock file ensures reproducible builds. So here's this cargo lock. And here's all these packages. Here's my guessing game. Are these all what is used by either cargo or Rand? So it's locking them? Cargo will only use the versions of the dependencies you specified until you indicate otherwise. In the lock file, the answer to this problem is the cargo lock file, which was created the first time you ran cargo build. Okay, so it grabbed the absolute latest regardless. In other words, your project will remain at 0314. Really? No, it won't. Liars. Okay, so in my toml file, I wrote initially 0314. And if I go back to that, if I undo this to 0314, I want to delete this cargo lock. Yes, do that. Why didn't you go away? Okay, I'll delete it via the command line. Oh, interesting. Okay, so remove cargo.lock. All right, now if I do rand 314, I've saved cargo build. Cargo lock, what do you say? Okay, this, I can understand this a tiny bit more. Just a tiny bit. It did lock it to version 3. However, patch version is not the same. Also, there's two rands in here. There's package rand 042 and package rand 0322. How do I know which one is being used? Yeah, how do I know which one is being used in the actual project? That's that is very interesting. I I am not sure I like this. Your cargo toml. So I can, well, sort of. It will just look at this version apparently. Are there symbols I can put this to really truly lock it to whatever version I want? Updating a crate to get a new version. When you do want to update a crate, cargo provides another command, update, which will ignore the cargo lock file and figure out all the latest versions that fit your specifications in cargo toml. It looked like libc or some when it required the latest version. Oh, so like, so one of something else required it to be a little bit higher. Where's Rand? Something else required a little bit be a little bit higher, and so it went up to the minimum increase to work completely. When you do want to update a crate, cargo provides update. Ignore the lock file, figure out the latest versions that fit your specifications in cargo toml. If that works, cargo will write those versions into the cargo lock file. But by default, cargo will only look for versions larger than 030 and smaller than 040. If the RAND crate has released 2 new versions, 0315 and 4, you would see the following. At this point, you would also notice a change in your cargo lock. Okay, so this makes it possible for me to not really care that much about how I use the toml file. I can just throw in 040 or 030 if I wanted to. So rustaceans are able to write smaller projects that are assembled from a number of packages. Okay. Lol rand 042 requires rand 0322. Is that what? Where do you find it out? Like, how do you find that? Because I'm not, it's not immediately apparent to me that there is this requirement here. The dependencies in the lock. So in rand 042, dependencies, fuchsia zircon, libc, and winap I. And I guess we can look through like libc. I'm not seeing rand 042 having rands down here though. Okay, so generating a random number. Let's start using rand. The next step is to update. Okay, so we need to extern create rand. That's different than just use. Interesting, they want us to put this above. So extern, I wish they called it external. Extern create rand. So use the external create rand. Use is just for namespacing. Okay, so instead of like going in, having to go in manually to standard IO. And then use So inside of rand, we want to extract the range method or class or function or whatever we call it. So use rand. Why don't you spell it out? Random number generator, yeah. Okay. So here's our input your new guess. Wait. Oh, here it is. Let secret number equals rand thread random number generator. So we're going to offshoot this to a thread, although it's going to do all the work itself. And it's going to generate a oh, interesting. So we don't have to declare a secret number first and like tell what type. It's going to figure that out. My guess is that's what let's doing for us. And it's going to generate a range potentially of integers between 1 and 101, and my guess is it's non-inclusive for the right number. Let's do this. Type inferencing, yes. I'm not used to using type inferencing. I haven't done that very much. Let secret. Okay, so our secret number is equal to we call rand. Okay, so I'm going to do this first. I want to try something different. So thread random number generator. So we're going to thread this off, and then we're going to run the generate. That returns an object or something that we can then run the generate range on and give it a number between 1 and 100 inclusive, 101 exclusive. And then we're just having the secret number is that. I think I'm just going to include this here. You guessed the secret number is that secret number. Okay, so if I build this, it should just work, right? Cargo run. Please enter your guess, 50. The secret number is 39. Okay, perfect. Why is this on a different line? It doesn't look like it should be that short. Let's try this. Yeah, that's very interesting to put it on the secret line. Yeah, you don't see a reason why there should be a new line in here either. But this is print line, you guessed. The new line is before this. Okay, so guess. Is this guess putting a new line in here? Is it because I pressed return? So literally it's the number plus the /rn. Ooh, interesting. So we're gonna have to strip this out, or when we convert this to a number, aren't we? That is weird. Auto inserting or just like keeping that in there. That is fascinating. Okay. It should go over that, but my guess is they put this as another print ln so that I wouldn't run into that yet, and therefore ask these questions. Maybe they'll go after that later. Okay, one thing I wanted to test, just to make sure I understand this, is I should be able to bring this thread range out, right? So can I say use rand thread random number generator like that, and then do this? Will this work just as good? Cargo run. No. Run. Enter your guess. 50. Yeah, okay, cool. So this is just a way for us, like as you were saying, Danny, to get and is it a reference? My guess is that I'm just sort of like putting this out into the equivalent of a variable or an alias, and it's a reference to location in memory where this function is. Oh, I could use curly brackets with that. So RNG and thread RNG all in one line. All right, that is really nice to know. That's going to make this a little bit easier to see and read. Especially, my guess is that we're going to have a whole bunch of these. Although I can do the opposite now too, right? Wherever these IO is, I could do std : IO here as well. So I kind of wonder what the can I change the name? Is there like an as, or I can say like, hey, range as random, like new random number or something. A whole bunch might call for rand. Oh, like if I'm calling them all out. Well, that's similar to like the true imports from C. Okay, that's interesting. So, do you know, Danny, if we if I were, when I'm doing this, is it in the compiler pulling this code out and injecting it in here? Or is it waiting to see what I use? I haven't used C++. I'll only C, so I'm not familiar with using in C++. All right, that is interesting though. So I guess I could be slightly less descriptive of my uses, and this should work as well. During the linking phase, it puts the reference to the creates functions in your block. Okay, and then when I compile for production, does it only put in the stuff that I use, regardless if I use it? All right, let's not do that. RNG and oh, what was it? Red RNG. Okay, so we have this. We want, what were we doing? Let's go back to the book. Okay, so we're adding external create rand. We'll put it at the top to let rest know that we're using external dependency. This also does the equivalent of calling used rand. So now we can call anything in rand create by prefixing it with rand : I'm not positive how much tree shaking it does, but considering it tree shakes for WASM, I'm going to guess it tree shakes for machine code generation. I would hope so. Like if it's trying to be like this new systems language that's going to be extremely small and extremely fast, that would make a lot of sense. Hey, don't do that. We're adding external. Let's see. Next, we're adding another use line to just grab it out. Also, we're adding 2 more lines in the middle. The thread range function will give us this particular random number generator that we're going to use. One that is local to the current thread of execution and seeded by the operating system. Local to the current thread of execution. Wait, so that's not calling a new thread? It's not going to create a new thread, like for behind the scenes? It's doing it in the thread that I'm running right now. This method is defined by the random number generator trait. The gen range, okay. Knowing which traits to use and which functions and methods to call from a crate isn't something that you just know. Instructions for using a crate are in each crate's documentation. Another neat feature of cargo is that you can run the cargo doc -- open command that will build documentation provided by all of your dependencies locally and open in your browser. Let's try it. Cargo doc -- open. Will it open the ones that were dependent on rand? I'm interested. Cargo doc, also no tab autocomplete. Oh, interesting. So it creates a local web server, or rather file, opens it up here, and lets me see, okay. Oh, cool, I can see the source. I can see libc is required, and rand, and all of its documentation. Oh, that's nice, so that I can use this potentially for offline work. All documentation in Rust uses this format with it, which is really nice. Yeah, this does look really nice. So I can look at all the functions. Thread RNG. Retrieve the lazily initialized thread local random number generator seeded by the system. Intended to be used in method chaining style. With like the generate. Okay. After generating a certain amount of randomness, the RNG will reseed itself from the operating system. The internal RNG used is platform and architecture dependent. Okay, so it'll figure out its own thing. Interesting. Okay, so there's thread RNG. There's a generate a random value using the thread local random number generator. Okay. There's some interesting about it. It doesn't look like it's a hugely featured, but enough to get basic numbers out. Is it gonna? Can I get a floats out of it too? An iterator which will continuously generate random ASCII characters. That seems like a very interesting feature to add in. All right, I am way off topic, and the other thing is, I'm just gonna finish out to the end of this section right here, and then it'll be the end of this stream because it is almost 8 o'clock. Okay, so the second line that we added to the code prints the secret number. This is useful when we're developing the program to be able to test it, but we'll delete it from the final version. Of course, it's not much of a game if it prints the answer. Try running the program a few times. Yeah. Secret number is 83. It's this, that you guessed. It's the new line right there. You should get different random numbers every single time. And we do. So need to remember we're at comparing the guess to the secret number. And I think what I can do, I'm going to copy this. And where do I want to put this? Maybe inside of guessing game. Because I will forget. I'm going to put in a new file where actually I'm going to do the readme. Currently at, boom. Save that. I'll push these all up. Let's see what we got here. We got a readme, our toml, and main. That's all fine. We'll commit these. Going through guessing game in chapter 2. Work in progress. Save that. And sync. All right, so this, I don't believe that I have live, I don't think I have any kind of like live watching up on there. So for the next time that I have my basic info, I will update the description to have a link to this this code. Also, once I finish through this chapter, I'm gonna begin going through and updating like a knowledge wiki with things that I'm learning, so that way that we don't have to like constantly look at this documentation and book again. But thank you, Danny, for stopping by and watching, and thank you anybody who watches this VOD. I know it's a little bit early in the morning, but it is. I feel that this is a really awesome time. Wake up, learn some new cool stuff, eventually do something fun with Rust once we learn it. And I am planning on doing the stream most mornings in April here on YouTube at 7 a.m. Mountain Standard Time or Daylight Time or whatever it is these days. With that, thanks again for watching, and I'll see you tomorrow morning. Have a great day.